my channel, don't forget to like, subscribe, and share, and make sure you click that bell button. All right. This was. All right. Hey, that was good. That was hard. All right. So let's get started. Analyzing linear graphs. Okay, example one. One thing I love doing when we do problems on money is I try to make them as realistic as possible. So both examples that we're doing today are realistic. I looked these numbers up online. So on average in Arizona, a car salesman earns $1,760 a month and receives $350 for each car sold. We're going to let C represent cars sold and I represent total income. This next sentence is something that you will see on standardized tests all the time. Write an equation to model the scenario. Okay? I'm going to start with my $350 for each car sold. Hopefully it's obvious it's going to be 350 times C. So if I sell one car, 350 times 1 would be an extra $350 that I'm going to make. If I sell two cars, 350 times 2 would be $700 extra that I'm going to make, and so on. Okay, I always get this $1,760 a month, so I'm just going to add it to the back. So guaranteed I get the $1,760, and then how much more I make is going to depend on what I'm multiplying times the 350 with those cars. Okay, and I'm just going to put my I in front. And the only reason I'm putting it in front and not the back is so now this is kind of in slope-intercept form. We've got like y equals mx plus b form. All right, and it wants me to graph it on Desmos, so let's do that. All right, so I've got y equals 350x. I switched my I to y. I switched my x to, or my c to x, and then I've got the plus 1760. Okay, right now it looks like it's just a vertical line, but that's because my slope is really, really steep. So if I change the settings on here, which is up in this upper right-hand corner where the wrench is, I'm going to change my y-axis to go from 0 to, I want this to be way bigger. Like 1760 is the lowest amount I'm going to make. If I sell more cars, I'm going to make more. So I'm going to do like 5,000. Okay, so now that my y-axis is counting by thousands, we see the slope more. My x-axis I'm going to keep as 1, 2, 3, 4. It's counting by twos, because that's just talking about each car. Okay. All right. So now let's see what they asked. How many cars need to be sold to make $6,000 in a month? I'm going to show you how to do it on Desmos very easily. But if we were to do it algebraically, we could do this. I could substitute 6,000 in for I, saying that I want my total income to be $6,000, and then I could solve this equation for C. So minus 1760 on both sides, divide both sides by 350. That would give me C equals some number, and that would be the number of cars I would have to sell to make the $6,000. Okay? Or, way easier if I just, on Desmos, plug in Y equals 6,000, remembering that Y is my income. So if I want my income to be 6,000, I'm just going to plug Y equals 6,000. And if I move up, I can see it graph that horizontal line and click on this intersection point. And so what this point is telling me is that when Y, or my income, is 6,000, I would have to sell 12.114 cars. Can I sell 0.114 of a car? No. Okay. So if I sold 12 cars, would I make $6,000? Not quite. I'd be just short. I have to sell the 13th car to get above $6,000. Make sense? Okay, so this one is going to be 13 cars. All right, could be done algebraically. Way more efficient to do it on Desmos. I would accept either way on the test. All right, what is the y-intercept and what does it mean in the context of the problem? The y-intercept I can tell just by looking because it's in y equals mx plus b form. The y-intercept is the b in the back, so that's 1760. So I'm going to write it like this. My y-intercept is 1760. Okay, second part to the problem. What does it mean in the context of the problem? What this is saying is like you have a real problem where there is a real person selling cars and making money. We are changing that into math, so we have equations here and numbers. And now when it's asking what does that mean in the context of the problem, it's asking me to take it back to the car salesman and money and all of that stuff. So I've been writing it like this. This y-intercept of 1760 is the salary before cars are sold. Okay, so salary before cars are sold. Kind of your starting point. This guy automatically gets 1760 each month. So that would be a salary if no cars were sold. You can live off 1760 a month too. That's low, but you can live off that.
Ramen.
All right. As the number of cars sold increases, the total income increases. At what rate is it happening? I really want you to start connecting the word rate or rate of change with the word slope. Okay, slope is the same thing as rate or rate of change. So at what rate is that happening? $350 per car sold. All right, that is the rate at which it is changing. All right, example 2. All right, I love this problem because it is very, very real. I made this problem during summer school, so in June. I do have a retirement account. In June, it had about $18,000 in it. Okay, and we'll talk more about it because I think it's great to talk about money. And what I put in, every paycheck I put $100 into my retirement account. And I get paid bi-weekly, so I get paid every other week like most jobs. So that means I put in $200 per month. And I'm adding that to my $18,000. All right, so this question is really just checking to see, can you look at the equation and understand what these different numbers mean? What is the change per month in the account? The change is $200. Okay, what is the starting amount? The starting amount would be my y-intercept. So that is $18,000. All right, so just being able to look at that equation, pick out your slope and your y-intercept and understand what they mean. Okay, and that is it for these notes.